Hello and welcome to my channel. In this lecture we'll be talking about the arm, so let's begin. Now to study the arm we should study first the bones on the arm. We studied the proximal end of the humerus. Now it's the shaft and the distal end of the humerus. Now the cut section, as you can see here, is almost triangular in cut section, has anterior, medial and lateral borders. Okay, anterior, medial border and lateral border, has anteromedial, anterolateral and posterior surfaces. Now there's also lower down on the lateral side, on the anterolateral surface, is a V-shaped tuberosity for the attachment of the deltoid. I think it's apparent here in this plate. There is a diagonal groove on the back of the humerus. It's called the radial groove, where the radial nerve and the profunda brachii artery run. It runs the groove from the medial lower down to lateral. Okay, there's also medial and lateral intermuscular septa. This is the medial intermuscular septum here, and lateral intermuscular septum that provides attachment to muscles and separates the flexors at front from the extensor muscle at the back, which is the triceps muscle. Okay. Also, we have medial and lateral supracondylar ridges, because the triangular cut section, rather becomes flat at the distal end of the humerus, and these are the medial and lateral supracondylar ridges or lines. Okay, and at the distal end we have a condyle, 2 epicondyles and 3 fossae. The condyle of the humerus, this is the condyle of the humerus. It's formed of 2 parts, the trochlea medially and the capitulum laterally. Capitulum is spherical in shape, as you can see here, and it articulates with the superior surface of the radius to form part of the elbow joint. The trochlea is medial, and it's a pulley-shaped structure. Medial boundary, or the medial border of this trochlea, is more prominent than the lateral border of the trochlea and extends to the back surface of the humerus. Okay, so this is the trochlea and this is the capitulum. The trochlea articulates with the trochlear notch in the ulna. So this is the ulnar part of the elbow joint, and this is the radial part of the elbow joint. The 2 epicondyles, this is the medial epicondyle, this is the lateral epicondyle. It's very obvious that the medial epicondyle is more prominent than the lateral epicondyle. And if we are hit in the medial epicondyle, we feel this, electric charge in the medial side of the forearm to the little finger, because the ulnar nerve grooves the back of the medial epicondyle. Okay. The nerve related to the lateral epicondyle is the radial nerve after becoming anterior to it. It was posterior and pierces the lateral intermuscular septum to become anterior to the lateral epicondyle. The median nerve in the middle, and this gives you an idea about structures injured in different fractures of the humerus. The supracondylar fracture for the median nerve. The medial epicondyle fracture injures the ulnar nerve, and the lateral epicondyle fracture injures the radial nerve. Okay, this is very important. While in the shaft, because the radial nerve passing at the back of the humerus, it is the structure injured in the fracture of the humerus, together with a bleeder from the profunda brachii artery. The 3 fossae we talked about. This is one fossa, this is the other. This is the radial fossa that accommodates the head of the radius during flexion. This is a coronoid fossa that accommodates the coronoid process of the ulna during flexion at the elbow. And at the back, this deep, big olecranon fossa that accommodates the olecranon of the ulna during extension at the elbow joint. So remember, we have the coronoid fossa above the trochlea, we have the radial fossa above the capitulum, and we have the olecranon fossa at the back. For two for the ulna, the olecranon fossa and the coronoid, and one for the radius, which is the radial fossa. Proximal end of radius, this is the radius, the proximal end, this is the head of radius, this is the neck of radius, this is the radial tuberosity at the posteromedial part of the, or on the medial surface of the radius, the neck between the radial tuberosity and the head. The head is disc shaped in the horizontal, see, disc shaped, and articulates, the superior surface articulates with the capitulum of the humerus, and the medial surface articulates with the radial notch on the ulna. This is the radial notch of the ulna to form the superior radio-ulnar joint, and the annular ligament holds the head of radius in place. The annular ligament. We will study this with the elbow and with the superior radio-ulnar joint. Okay, so this is the proximal end of the radius. The proximal end of the ulna, as you can see here, it's prominent, bigger than that of the head. The head of ulna is distal, not proximal. This is called the olecranon process. It has a trochlear notch to articulate with the trochlea of the humerus. The superior border of the olecranon receives the insertion of the triceps muscle, and the coronoid process of the ulna, this is the coronoid process of the ulna, shares in the formation of the trochlear notch and has the ulnar tuberosity in front of it. This is for the attachment of the brachialis muscle, and on the lateral side there is the radial notch on the ulna to articulate with the head of the radius to form the superior radio-ulnar joint. So remember, the olecranon, the coronoid process, the trochlear notch, and the tuberosity of the ulna. Now the arm fascia, superficial fascia and deep fascia. The superficial fascia continues with that of the rest of the upper limb and the trunk. The deep fascia, as we studied in the lower limb, it's the same principle. The deep fascia invests individual muscles and forms septa. It forms the medial intermuscular septum and the lateral intermuscular septum that separates the muscles of the arm into the ventral or flexor compartment and dorsal extensor muscle, which is the triceps muscle. Okay, the lateral intermuscular septum provides attachment for the brachialis, the triceps, extensor carpi radialis longus, and brachioradialis. It's pierced by the radial nerve coming from the posterior surface, coming out of its groove on the posterior surface of the humerus, and also pierced by the anterior branch of the profunda brachii artery. The medial intermuscular septum, on the other hand, provides attachment for brachialis and triceps muscles and pierced by the ulnar nerve and the superior ulnar collateral artery. Ulnar nerve and superior ulnar collateral artery. The brachial muscles now. On the anterior surface or the anterior compartment, the coracobrachialis and biceps brachii. The posterior compartment, only one muscle, which is the triceps muscle. The coracobrachialis arises from the anterolateral border of the coracoid process, medial to the origin of biceps short head from the coracoid process. So remember, the coracobrachialis to the coracoid, short head of biceps to the coracoid, and pectoralis minor to the coracoid. These are the muscles attached to the coracoid. You will be asked about them. Pectoralis minor medially, and laterally the short head of biceps and the coracobrachialis muscle. Okay? Inserts in the middle third of the middle border of the humerus. It's pierced by the musculocutaneous nerve, as you can see here, and supplied by the musculocutaneous nerve. The brachial artery is felt behind it, and the action of this muscle is flexion at the shoulder joint. It passes in front of the axis of the shoulder joint. Nerve supplied by the musculocutaneous nerve. This is the coracobrachialis muscle. The biceps brachii muscle, it has a short head and long head. This is the short head, which is medial, long head, which is lateral. They unite together to form one muscle. The short head arises from the coracoid process. The long head arises, remember, inside the shoulder joint. And, the synovial membrane forms a tube around the tendon, this tendon of the long head of biceps arising from the supraglenoid tubercle. So remember, the supraglenoid tubercle for the long head of biceps, while the infraglenoid tubercle for the triceps, the long head of triceps. Okay, inserts, by the origin by two tendons, insertion by two tendons also. One spiral or twisted tendon to the back of the radial tuberosity, and you can feel it when you flex the elbow in the cubital fossa, and an aponeurosis from the tendon blending with the deep fascia of the forearm to the posterior border of the ulna. The nerve supply is by musculocutaneous nerve, which is deep to the muscle on the brachialis muscle, and the action is flexion at the elbow, but do not forget the supination action. It's a powerful supinator. Observe that, when you handle a screw, a screwdriver, to obtain a forceful action on the nail or on the screw, you find yourself, bending your forearm or flexing your forearm automatically to operate the biceps. If you extend your upper limb and put your other hand on the biceps and do pronation and supination, you will notice that the biceps is not moving. But when you flex the upper limb while still the hand still on the biceps and you do pronation and supination, you will observe that the biceps is moving now, is contracting now. Okay, do it on your arm. Feel the biceps in extension while doing pronation and supination, and feel the biceps in flexion while doing pronation and supination. The brachialis muscle is a deep muscle attached to the lower part of the shaft of the humerus, lower half of the anterior surface of the humerus, and the lateral surface as well, embracing the deltoid tuberosity and the intermuscular septum. It inserts in the ulnar tuberosity in front of the coronoid process and the coronoid process as well. It forms the floor of the cubital fossa together with the supinator and supplied by the musculocutaneous nerve, which lies on it, covered by the biceps brachii muscle, and also supplied by the radial nerve. So it has a double nerve supply. The nerve supply of the brachialis muscle by the musculocutaneous nerve and the radial nerve. The action is to flex the elbow, just flexion at the elbow. Okay, the last muscle we'll be studying is the triceps in the posterior compartment muscle. Has long head, lateral head, and a deep medial head or middle head. Okay, the long head from the infraglenoid tubercle medial to the lateral head, and I was asked about that before, which is the most medial head of the triceps, the long head or the medial head or the lateral head? It is the long head, more medial than the medial head or the middle head. Okay, the long head from the infraglenoid tubercle medial to the lateral head, and passes posterior to the teres major, anterior to the teres minor. Passes again posterior to teres major, anterior to teres minor, and forms a boundary for both the triangular space and the quadrangular space. Now the long head, it's vertical when the limb is adducted. If you abduct the limb, the long head will become horizontal. It will support the descended head, of the humerus in abduction. So it's attached to the infraglenoid tubercle so that it supports the head of the humerus when you abduct your arm. Okay. The lateral head from the lateral surface of the shaft of the humerus and the lateral intermuscular septum. The medial head, covered by the lateral and long heads, arise from the distal part of the posterior surface of the shaft of the humerus. Now the heads converge to a tendon, strong tendon that attaches to the superior surface of the olecranon process. Nerve supply of the muscle by the radial nerve, but you must know the pattern of supply of the triceps, so that the radial nerve first gives the long head, then the medial head. This is before going into the groove. Then in the groove of the humerus, it gives the lateral head and the medial head again. So the medial head receives two branches of the radial nerve. Again, before the groove, the radial nerve gives the long head, then medial head, LM. Then in the groove gives the lateral head and medial head again, LM, LM, LM. Okay? You must know the pattern of supply of the triceps. Then the nerve distal to the groove branches to give the brachialis, brachioradialis, extensor carpi radialis longus, and the lower lateral cutaneous nerve of arm. Now the action of the triceps extends the elbow. Long head supports the shoulder, as I told you before, during abduction. There is a small muscle called the articularis cubiti, like the articularis genu of the lower limb. The articularis cubiti is derived from the middle head or the medial head, and it's attached to the upper part of the synovial membrane of the elbow joint posteriorly. Because in flexion, the synovial membrane is pulled down. Now, back in extension, there's nothing to pull the synovial membrane up instead of being torn during the action of extension. So the articularis cubiti pulls on the synovial membrane during extension together with the triceps muscle to avoid injury to the synovial membrane of the elbow. The nerve supply also by the radial nerve. Okay, this concludes our talk about the muscles of the arm. I hope you got the maximum benefit from this lecture, and thank you very much for watching.